All right, Jam, are you ready to talk about toasting herbs, gravity, and all kinds of things that relate to chemistry and our everyday lives?
I think I am. I think I'm ready to ask you those questions, and I don't think I have much to offer in the way of answers. So
All right, let's get into it.
let's do it.
Hey, I'm Melissa,
I'm Jam,
and I'm a chemist,
and I'm not.
and welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Sorry, I pulled away a little bit from the mic. I'm cross-legged, which makes me want to be more wiggly, I think.
That is A-okay. I think people still heard you. This is
Okay,
Welcome
great.
to Ask a Chemist, where you are asking a chemist. Well, by way of me.
Nice.
And your questions that we've been receiving through various ways and responses to other episodes or totally new questions are coming right now into this room to this chemist right here.
Mm-hmm.
And she's not allowed to leave until she gives you an answer.
I could walk out this door right now,
I mean,
but I don't want to.
But do you want to, all these good people with those good questions,
yeah.
how could you?
Yeah, I don't want to, yeah.
Okay. So this first question is from Evan on Instagram. What does toasting herbs actually do?
Okay, I think this is all just chemistry off the cuff.
Okay.
But I think that toasting herbs does two things. One, I think if the heat facilitates chemical reactions similar to the Maillard reaction, which creates new molecules that have a tasty flavor profile. And then I think the other thing that it does is it gives a lot of those organic molecules enough energy to turn into gaseous molecules instead of being in their solid or liquid state. And then you can smell them more, so I think that those are the two things that happen when we toast herbs. And that's why it smells so good and also why it slightly changes the flavor.
Interesting.
What do you think? Does that check out?
Sounds good to me. I was going to say, too, that depending on how much you toast them, would the removing of moisture make them last longer?
I think, don't you toast them right before you cook with them?
Well, I wasn't really sure what his phrase meant, but probably so. Like, I didn't know if he meant like...
I would think that would be dehydrating them.
Yeah.
To get all the moisture
Yeah.
out.
I was thinking how like there is like paprika and there's smoked paprika.
Yeah.
So it's like there's something that's been done to it. Obviously, the smoking of it. And then it's still a like use later state, or form. But yeah, I think what you said makes more sense.
Okay, great.
This question is from Ed on Instagram. Does gravity affect how elements bond to each other?
Okay, this is a great question, Ed. And I think if you're not, maybe you should consider being a chemistry major because we have a whole class on this. So gravity is physics, right?
Gravity.
You're so pleased with yourself.
I was just thinking like there just was like I couldn't stop it from, there's just the song that says it over and over or whatever.
Well, gravity is physics, and there is sort of this like threshold at which like most things that we interact with are affected by classical physics, like gravity is considered classical physics. So basically everything we interact with on a daily basis is large enough that it would be affected by physics.
Yeah.
But when things get to a certain smallness, they have this ability to sometimes not be affected by classical physics and instead act like light waves. And so gravity sort of does, but it also sort of doesn't.
I think it was a little like I as a person who likes to listen to science podcasts and watch little science YouTube videos and stuff, I think I saw a YouTube short about this, not exactly this, that wasn't asking specifically about like elements bonding to one another, but it was something similar. And it was like, what's his name? Brian Cox or somebody like that. One of those physicists. It was like basically at that smallness, there's just not enough mass for gravity to matter a lot. And it's so weird because I probably watched that like 2 weeks ago. And
Yeah.
here this question is coming up now.
We've talked about it before. It's like the duality.
Right.
Mm-hmm.
But also, yeah. And it's like it's been referenced so much by you, but it is just still so weird whenever someone asks the question in this way, straight up.
Yeah.
Not just as part of another explanation, but like, yeah, so why isn't it that gravity is affecting these things? Or is it?
Yeah.
And it's like, yeah, how weird and cool and unfair also. Like, wouldn't it be cool if we could just not have gravity affect us temporarily in some cool way?
And there's crazy stuff that happens. Like there's something called tunneling where like electrons are likely to be in this area and they're likely to be in this area. But if they're never, ever likely to be in between, how does it get from this area to that area?
Whoa.
Yeah.
What the heck?
Math. I took a class where like we derived all the equations of like where electrons are likely to be around an atom or whatever. And it was really hard, but it was really fun and interesting. And I worked so hard to barely understand.
What was that class called?
Physical chemistry.
Physical chemistry.
And the other half of physical chemistry is about like the heat. Mason took a similar class to that whenever he was in his engineering degree, but it was called thermodynamics. So there's half of physical chemistry is thermodynamics. The other half for us is quantum physics. So it's like what's happening. What is the physics of these little tiny particles, basically?
Wow. So weird. So crazy.
Yeah, I still can't believe I took that class and passed it. I think about it a lot. I saved my notebook. It's like the only notebook from undergrad I have. Actually, I have 2 notebooks from all of undergrad, and that's one. And the other was just like a synthetic class we had to do. Yeah.
Interesting. Huh. This question's from Gypsy on Instagram. I believe we've had questions from Gypsy before. What is the point in creating new elements that have such small half-lives?
Gypsy, this is such a great question. I rant about this in class just the other day. Okay, here's the thing. There are some people who believe like, all right, well, any fundamental exploration, we may not know the point of it, but if we don't explore it, then we'll never learn what's potentially there. So that's the argument. It does sometimes feel to me like a little bit of a waste of resources to spend all this time and energy creating super heavy metals that don't exist for very long.
Right.
But there is a theory that somewhere in these super heavy metals, there's an island of stability where they may last longer. But yeah, I kind of agree. I personally would probably be spending those resources on other things, like meeting some basic human needs first. But I do understand that both of them are worthy pursuits.
Right.
But it is, sometimes I'm like, this is a lot of resources, and not just like financial resources, but like energy, non-renewable resources to make, the way they make these super heavy metals, for those of you who don't know, is they like literally sort of shoot an atom with some electron or something at it to be able to get 2 atoms to fuse together, sort of, to basically get the right number of electrons to make a new thing. You're just shooting atoms at each other, kind of, to get these new things. And they break down so quickly that oftentimes they only exist for like fractions, very small fractions of seconds.
Interesting.
And once you've made it, then we have a new, atom, and we can fill in this name on the periodic table. But and a lot of this have been discovered like in my time since I started grad school or, like since I started college. But I do have questions about, maybe the ethics of exploration for the sake of exploration when it's not clear that it's leading somewhere, and we have finite resources,
right. Yeah, it'd be interesting to hear what people who are spearheading that, what they think. Like, would they have a defense of that, or would they?
I'm sure they would. They're really good.
And would it be very winsome? Like, would I be like, okay, I see.
Yeah.
Winsome.
That's a good use of that word. My friend said reasons why. If my friend gave me this book when we were in college, it said reasons why you are the best friend in the world or something. It was like a little book like that you filled in these blanks, and one was you're the world's best and she filled in the blank chemist. And I found it recently and I read that to her and said, that's just not true. You just lied about that.
Yeah.
I am not the world's best chemist, but that is so sweet of you to say.
Yeah.
So these people are like really good chemists that understand really complex things that I probably can't even grapple with. But yeah. So I'm sure they would have a good argument. I don't know how winsome it would be, though.
Right. Okay, this next one's from Sierra on Instagram. How does cough medicine work?
Well, there's lots of different cough medicines. And I actually kind of have a rule against looking things up, but I did do a little bit of perusing. And there's a few different types of cough suppressants.
Right.
Speaking of medicine.
Yeah.
I'm recovering from a little bit of a cold and currently on some that's wearing off. And so my body's starting to be like, get it together. Get it together, Kalini. I had to go to a meeting I really didn't want to when it was just starting. And I said, dig deep, Kalini. Okay, so there is cough medicine that like suppresses the actual reflex to try to cough. And there's cough medicine that tries to basically break up what is already there to make it easier to expel.
You're right.
But there is some evidence that like cough syrup, and a lot of those things also are kind of like just sedating. They have sedative effects so that you can sleep basically through the cough.
Right.
But there is evidence, shout out to your wife, who told me to look this up, and I did. And there is evidence that in children, cough syrup is like roughly similar equivalent efficacy of using a spoonful of honey instead of cough syrup. And there's negative side effects with cough syrup that there aren't with honey.
Right.
So that is fascinating.
Yeah. Very weird.
I feel like there is the like concentration of sugar in honey could have some benefits, like what we're talking about with osmosis, where maybe it like does it soak up all the water inside the bacteria or something? Who's to say? So it does, and I have used that honey trick before, and that has worked. But so that's kind of we'd need a more in-depth question or a more in-depth episode to be able to fully answer that. But that's some of the feedback on it, and look into just getting a spoonful of honey. Yeah, and there is research that backs that up.
It's like a spoonful of honey is a medicine that can go down in some scenarios, you know?
Exactly.
But yeah, we do that. We've done that quite a bit when our kids are sick and coughing through the night and stuff. We're just like, let's just do this. We have this already. You know, it's like we've already got that on hand. And of course, there's the side effect situation where it's like, yeah, I mean, maybe this isn't the bestest thing you could ever do, but it has a positive effect and we've got it. So no harm, you know?
Yeah, for sure.
Interesting. Ready for the next one?
Yep.
This is a bit of a long one, but it's really good. From Chelsea, one of our patrons, a member of our Chem community. Shout out, Chelsea. Hey, I have a hot take. We love hot takes around here. I have a hot take on food dyes I wanted to share. I think all food dyes, even the naturally derived ones, shouldn't be allowed. I developed a natural food dye allergy when I was 25, and it took me months of cutting out foods and comparing labels before figuring out the culprit, annatto, a yellow/orange spice used as a natural food dye used in the vast majority of orange cheeses and other dairy products such as coffee creamer and vanilla cake batter ice creams. The more I researched allergies, I discovered that natural substances are more likely to trigger allergies than synthetic substances due to the presence of proteins. I personally do not think we should be increasing exposure to potential allergens, especially not for aesthetic purposes, and not in a country like the U.S. that has poor labeling practices. It would be a rough adjustment, but people only expect colorful foods because they've been taught to. So why not unteach that to protect people's health?
Yes, Chelsea. Preach. We love it. Louder for the people in the back, Chelsea. Yeah. We're here for this. Yes, yes, yes. Okay, yes, I totally agree with this. I think this is a great take. I I feel like that I was sort of seeing a microcosm of that where I'm like, yeah, why are we making these artificial dyes that might cause problems? For what? For aesthetic purposes? Seems like a risk we would avoid taking.
Yeah.
And this is a great argument for broadening that and saying, why do we have dyes at all? Even naturally derived ones can still cause problems and they don't really benefit or enhance the food.
Right. Yeah, it's very interesting to me that like, yeah, you ask one question and it does start to beget another and another. It's like, okay, why are we changing the way our food looks in the first place? Now, what's hard about that is I certainly understand certain areas of food where the look is kind of everything. And there's a bit of a, okay, exception for the folks who want exception. For instance, like a decorated cake or something.
Yes.
It's like, there's something there, like, of course you do not have to, but it is a unique and special thing that gets this kind of treatment. But we don't need our cheese, as a great example in there, Chelsea. We don't need our cheese to be yellower or something. Who cares?
Yeah.
Seriously.
White cheese is just as appetizing to me as yellow cheese.
I just don't. It's so weird. And I'm sure that it was like this snowball effect of a little bit of that back in the 50s or something. Just was like, whoa, people really like how yellow this cheese is.
Yeah.
Like they think there's just a weird, even though we didn't say anything, they see yellower cheese, they think better cheese.
Yeah.
And it stuck out from the aisle and then everybody started doing it. But it's like, why don't we just all not do that?
Yeah.
And then why don't we just be like, does it taste good?
Yeah. And hey, I know, why don't you get color into your diet from a variety of fruits and vegetables?
Yeah, there's already our color. Yeah.
Yeah. I've been eating, Mason and I love ceviche, which I know you don't like shrimp.
Right.
But you like everything else in the concoction.
Yeah.
We recently found a tropical version. So it's got
like mangoes or something?
Oranges, mangoes,
nice,
tomatoes, red onion, avocado, jalapeno. And then like we get a variety of tomatoes. And that is the most colorful meal.
Nice.
And it's not artificially dyed. It's just tomatoes and avocados and oranges and mangoes. It's great.
Totally. Yep.
So get your foods get the colors of the rainbow from your foods.
Totally.
And let's not add dye.
Yeah, or like you want to like see a lot of colors, like get some paint. Do some painting. Get some color pencils.
And I do agree, like decorated cake if you want. That's cool. Yeah, sure.
Totally. It's like, but then you're opting into that instead of just being like, well, the cheese I have access to is just like this. I'm not gonna spend a lot of money for a more natural cheese that I don't have the money to spend.
Right.
Why can't the cheese I can afford, why can't it just not have something in there that I don't want?
Exactly.
That it doesn't need to have.
I agree.
Preach it, Chelsea.
Yeah, we love a hot take. Write in your hot takes.
Yes. Chemistry hot takes. That would be a cool episode. This is from Crystal on Instagram. Hi, I just listened to the episode about bleach, and I have a question about what you said about acid creating holes in our clothes, but only after being washed. I'm a high school chemistry teacher, and I'm convinced I have some kind of corrosive chemicals on my desk, lab counter for demos, because a lot of my shirts have holes right below my waist where I would potentially be leaning on my counter. I rarely do demos in my classroom because I have a separate lab not connected to my classroom, and my classroom lacks enough safety measures to do demos in there anyway. So I don't think the chemicals are from any demos I've done, but maybe from previous teachers. Is there a way to clean my counter once and for all so I stop getting holes in my shirts? Will it be possible for our janitors to have some sort of corrosive substance in their cleaning supplies? So I'm just doomed to ruin many shirts unless I wear a lab coat every day.
Okay, this is a great question.
What the heck? That's interesting.
Okay, one thing I think, and I messaged Crystal this, and she's like, it's so many holes. I don't know if it's that. Lab benches tend to be right at waist height where your buttons are. And your button is often, a strong metal thing in your pants. And your shirt is a thin fabric, and then the bench top is a hard thing. And I got a lot of holes right along that belt line when I was working in the lab, not from chemicals, that once I started tucking in my shirt, I just didn't really get them anymore.
Okay.
And so if it's a lot of little holes, I think it could be that. Even if it's a lot of them, that was something that consistently happened to me. And when I started tucking in my shirt, that's what it was. Now, what I've seen for acid holes, they're big, like large acid holes. But if you think that something's going on, I would take the approach whenever I'm trying to clean something and I can't get it out, I typically will try to use a base. So like baking soda, sprinkle it over, just a little bit of water to neutralize it. And then I do an acid, like a vinegar, like a safe acid, like vinegar, that will then neutralize, if it's a basic thing, neutralize it the other way. Oh, yeah. And then I usually just finish with soap and water.
Nice.
So a lot of times I will do, and I don't mix them together. This drives me crazy when people do this.
Right.
Because baking soda and vinegar just react with each other, and then maybe they're just a good paste, but they're not doing anything else.
Right.
But I would do in stages, like do a baking soda clean, rinse it with water, do a vinegar clean, rinse it with water, then do a soap and water clean. And then that's what I would do.
Yeah. Okay. Cool.
Or if you're worried it's acid, do the vinegar first, then the baking soda, whatever.
Yeah. Interesting. This is from Doreen. And we referenced Doreen.
Oh, wait. I do want to say one more thing to Crystal. It just occurred to me.
Oh, sorry.
Make sure you're getting the side of the bench top too. Where it's like don't just get the top, but if it's on the like rim, because there's usually like thick edges like on counters, clean that part too.
Yeah.
Okay.
Nice. From Doreen. Hi, Melissa and Jam. I started listening to your podcast last summer and found it very interesting. I always begin podcasts at the very first episode, and I've been listening to a lot. So I'm almost caught up now. I really enjoyed the chemistry experiments that Jam did and what you could do at home. So I'm sad those are no longer part of the routine. I'm a chemistry teacher, ages 14 to 18, who also does a lot of small experiments with younger kids from friends. So I enjoyed being able to extend my repertoire. Another thing, Melissa, you have complained about the name hydrogen bond in English because it's not a bond. So maybe you'd like the Dutch way of calling them, namely hydrogen bridge. Maybe you can start a new naming trend in English. Last thing to add, thanks so much for making this podcast. I learned a lot and I have a lot of interesting facts for my students during the chemistry lessons. Have a great day. Keep on going.
Doreen, this message made me so happy. I already mentioned it in the last video or the last episode. This is just, there's so many nice things in this. So first of all, also Doreen included a little bit where I was saying her name wrong. So sorry about that. I adjusted it. But I love hearing about you, like starting at the beginning of the podcast and listening all the way through. And then that feeling when you get caught up and you're kind of sad. I remember the first time I ever had that. And I was like, so it's fun to imagine people doing that with our podcast. But also, I also really enjoyed those chemistry at home experiments. They just were a little too time consuming. We do have a little bit more time in the summer, so I might try to bring them back. If not this summer, maybe in future summers. But we are starting to re-release some of them. So even though you've recently gone through all of them, just to kind of get them back into circulation and see how people are liking them, we're going to work on re-releasing them. And then let's see. I love the hydrogen bridge. I am going to start calling it that. I'm going to give that example to my students. That's awesome. And the last thing you said was, thanks for making this podcast a lot. And I do want to thank Jam. I've been thinking a lot lately about how much he has made this possible. And it's made for me so much about the way I teach better. And I do have a lot of interesting facts for my students during lessons too. And so I've learned as much as all of y'all have probably. And so, yeah, I really appreciate that from Doreen. And I appreciate you, Jam, for facilitating this, because sometimes I am just blown away by the fact that we're doing this.
I know. And it really is crazy that having a reason, obviously you're submerged in the world of chemistry all the time anyway, but you have this weekly reason to have to venture into a different area and research something different, and having that for anything, like, you know, in any part of our lives where it's like, oh, I'm taking a class on this, or I'm doing a thing on this, or I kind of got sucked down this rabbit hole about gardening or about this or whatever, ends up always kind of enriching our lives as lifelong learners. And so it's cool that you, in order to teach me and us, get that experience that you would always probably be interested in, but wouldn't have this recurring reason to have to always do it.
Yeah,
it's
good accountability to learn everyday life applications and context-based things. Like, I always had the ability to learn all this stuff, but I wasn't going to do it regularly, you know?
Yep.
And so it really has made my life a lot better.
Okay, we got some short ones here toward the end. From Katie on Instagram. Hot take on the politics and research defunding ? Which we did do an episode about that.
We did do an episode on that. I'm concerned. I think there's going to be a lot. I mean, for a more nuanced take, you can listen to that episode, but it's not good. I have seen already a lot of things. My sister, who I meant to ask her for her thoughts on this. She was in town actually when I was working on this, but she has, does a lot of grant work. There's a hair on my microphone. It's like tickling my lip.
It would belong to probably one of my kids who came and pulled your mic out of its thing the other day.
That's kind of cute though. So she does a lot more work on grants, and she has talked about like they're putting together this like really revolutionary thing for insurance in coastal communities to help with resiliency, because as the climate is changing, you know, there's a lot of more major weather events, and they have been given years of this grant already, and now the funding is pulled. And so thinking about like, I just don't think people have wrapped their mind around how much waste is happening. It's like, if I spent 4 years on this grant thinking I had 7 years, and now we're pulling the plug before we get the final results or before we have gotten to where we were trying to go. Yeah. You've now wasted 4 years of government money.
Right.
Because we didn't get to the end goal. And so maybe you're stopping the bleeding in the short term, but like in the long term, I think a lot more waste is being created by this upheaval.
Yeah.
So that's my hot take.
Yeah.
My hot take is it's not well thought out.
Yeah. Yep. And then Kaiba on Instagram, similar topic here, said, "Are you okay? Trump policies are affecting even science here in Brazil."
I am okay. I am worried. I think other people are affected a lot more than me. And I think for me, I have my students. So like for me, every day I have a reason to get up and go into work. And I know that I'm making a difference by working with them. But in the big picture, I am worried. And there are other people who are a lot more affected than I am. I'm really worried about grad students, people trying to get jobs. I mean, I've seen the way that it's impacted them, and it's not good.
Yeah.
And so, and then like my sister, she is being so much more affected than I am. And I think she's really discouraged, you know, and like, so are a lot of people in that field for good reason. So I'm okay physically and for the most part, mentally and emotionally, but not everyone is. And I am concerned. And financially, I'm also okay. My job's not an immediate risk, but if things keep getting defunded, schools will have to cut back. We're already going through budget cuts. There, to me, could be a world in which if the economy keeps getting worse, people aren't enrolling in school in the same numbers. And that could really affect me. So I do have some questions. There's a lot of uncertainty, but overall, I'm okay.
Yeah. Would you like to read these last two encouraging things?
Sure. I wanted to end on a high note, right? So these are some nice messages we got on YouTube from Bruno W. Said, "My new favorite podcast." I was like, that's so nice.
Yeah.
So thank you, Bruno. I was going to say you're our new favorite listener, but I don't know. But we have a lot of really great listeners. But.
Yes, but you are among a group of people that are our favorite people, our favorite listeners. So welcome to a cool group that has a lot of great folks in it.
And then on a form submission on the website, Jay Hunt wrote in and said, I really appreciate your podcast. Decent chemistry podcasts are few and far between. So that was nice too.
Yeah, it was interesting. That extra comment there was like, I'm guessing that Jay Hunt has looked at and listened to many different types of podcasts. And so just adding that in there was like, okay. All right,
yeah, that was nice.
Yeah.
All right. Well, I think that's all of them for today.
Yeah. So if you have a question, you can tell this is where they end up. Many of them, if they don't become a full-on episode. So we'd love to get your questions, follow-ups to any of these questions, follow-ups to recent episodes you've been hearing. Even ones if you're working through some of our older episodes, we love when a question from those comes up too and kind of gets to add on to those. So send those to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts, ideas, questions with us. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. That's patreon.com/chemforyourlife to join our super cool Chem community of patrons. We got multiple tiers of ways to say thank you, different perks you get for keeping our show going and keeping it free for everybody. Everybody gets an ad-free feed of the show. Everybody gets an extra bonus episode every month. And then different folks get different perks depending on which tier they choose. But all of them are dear to us, and we are grateful for our community. But if you are not able to do that, you can still help the podcast by subscribing on your favorite podcast app, rating and writing a review on Apple Podcasts, subscribing on YouTube, and leaving a comment over there. Those things help us to share chemistry with even more people, help more people to find us, and learn about the cool chemistry that is happening in their everyday life.
That's right. This episode was made possible by, This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer. He makes all this wonderful sound happen, and I'm so thankful that we are able to do this. And this episode was made possible by all of you, and especially by our community. So thank you to all of our listeners, but an extra special thanks to Julie S., Heather R., Autoclave, Chelsea M., Doreen V., Scott B., Jesse R., Sierra L., John T., Jeanette N., Cullen R., Erica B. If you're on YouTube, you can see I can't help but smile whenever I read this list because it's just so cool how many people are so supportive. Elizabeth P., Sarah M., Rachel R., Latila, Katrina B., Suzanne P., Venus R., Lynn S., Jacob T., Brian K., Emerson W., Christina G., Timothy P., Stephen B., Chris and Claire S., Chelsea B., Avishai B., and Hunter R. Thank you all so much for supporting us and making this possible.
And we actually do have a reference like Melissa referenced earlier from this episode. So if you'd like to check out the single reference from this episode, you can look at the show notes or in the description of the video on YouTube. And yay, chemistry.
Yay, chemistry. Yay, questions.